A very good afternoon to all of you. This is C.H. Venkataparao. I am working as an assistant professor in the Department of Pharmaceutical Chemistry. In this today class, I am going to deal about introduction to the pharmaceutical organic chemistry. In the introduction of pharmaceutical organic chemistry, what are the basic things, basic concepts we required to understand the chemistry concepts in this pharmaceutical organic chemistry too. Let me see one by one. And I think so you had already learned in these concepts in the previous semester pharmaceutical organic chemistry 1. Already we are most familiar with the organic chemistry basic things, but in this today's first class I am going to recollect these basic concepts once again. Right, let me see one by one. Now let me see the definition of organic chemistry. Our subject is pharmaceutical organic chemistry. Let me see what about organic chemistry. What is the meaning of organic chemistry? Organic chemistry is a Organic chemistry is a branch of chemistry. Yes, it is a branch of chemistry. In the chemistry, there are different branches are there. One is we are studying about, that is organic chemistry, inorganic chemistry, physical chemistry, analytical chemistry. You all experienced in these entire 4 years what type of different branches of chemistries are there. Right, let me see that organic chemistry is a branch of chemistry. What we are going to learn in this department, in this branch, let me see, that studies Organic chemistry is a branch of chemistry that studies the structure and properties, reactions of organic compounds which contain carbon in a covalent bonding. Let me see what are the things we are going to learn in this organic chemistry and what regarding organic compounds. See here, I am going to highlight those things what we are going to concentrate to learn. Organic compounds, this is a one term. What is the meaning of this? And the same way, carbon in covalent bonding, we need to know these things. One is a covalent bonding. What is covalent bonding? And what are the organic compounds? And regarding these organic compounds only, we will learn. One is the structure, another one is the properties, and the next thing is chemical reactions. Right, let me see what is covalent bonding. Carbon in covalent bonding. See, if you observe this, organic compounds which contain. What is organic compounds definition? I want to explain that. What is organic compound itself? Carbon containing compounds. First theory come up to define organic compounds is carbon containing compounds we can consider as a organic compounds. The second theory is those organic compounds more specifically the definition of the phenomenon of the organic compounds is updated as those compounds having carbon, and another phenomena is at least one carbon hydrogen sigma bonded system, one carbon hydrogen single bonded system. Here again this single bond I am calling as a single bond. This single bond I can call it as a sigma bond. That is one of the covalent bond. Sigma bond is a type of covalent bond itself. Covalent bond is of two types. One is a sigma bond, another one is a pi bond. What is covalent bond? Let me see. Covalent bond, how can we define? Covalent bond is a chemical bond. Covalent bond is a chemical bond which is formed by the two species. I am going to take these two species as A and B, and these two species form a chemical bond by mutual sharing of electron. Let me see. A has a 1 electron and B has a 1 electron itself. Now what is going to be do here? A is going to be shared to this B and B is going to share this electron to the A. Mutual sharing of electrons. For example, let me see again. This A has having 1 electron and B is having 1 electron with it. And those two species or those two elements have 1 electron each, and they are involved in the mutual sharing of electrons to form a chemical bond. The relationship formed between two species due to the mutual sharing of electrons, I can call it as a, that chemical bond I can call it as a covalent bond itself. Now the point is organic compounds. The point is organic compounds which contain carbon in a covalent bonding. For example, I am going to take best example is methane. Best example is methane. If I want to see the structure of the methane itself, let me see. If you observe here, carbon valency is 4. A valency I am going to mention like this. This is a carbon valency 1, 2 electrons, 3 electrons and 4 electrons here. The carbon valency, the 4 electrons I mentioned there. How can we know that carbon valence? How can we figure out valency of the one element? Let me see. For a carbon I am going to write the electronic configuration. 1s2. Carbon atomic number is 6. Carbon atomic number is 6. I am going to write the electronic configuration for that. 1s2, 2s2 and 2p2. Now how can we define the valency itself? Valency is nothing but outermost, the electrons present in the outermost shell. If you see here, what is this number indicating here? 1, this 2. This value indicates that shell number. Around the atomic nucleus, the orbitals are existing as a shells. And this is a first shell with respect to nucleus, this is a second shell, this is a third shell. Now in this representation, in this electronic configuration representation, this 1 indicates first shell. The 2 electrons are occupying the s orbital of first shell. For example, I want to mention here with respect to carbon atomic species, this is s orbital. There are the 2 occupying electrons in the first shell. Now coming to the second shell, if you see that this 2 indicates the second shell. For example, this is the second shell. In the second shell, s orbital is there, at the same p orbital is there. I can mention those things. S orbital is there, at the same p orbital is there. In s orbital, how many electrons are occupying? 2 electrons are occupying. In p orbital, again 2 electrons are occupying. That is a thing regarding the carbon atomic model. This is a carbon electronic configuration, this is a carbon atomic model. Now from this electronic configuration, from this atomic model, how can I identify the valency? How can I figure out the valency based on the phenomena? Let me see what is the definition of valency. Valency is defined as those number of electrons present in the outermost shell. If you see this atomic model, with respect to this is the nucleus, this is the nucleus. With respect to nucleus, this is the first shell, this is the second shell. These 2 shells I am discussing about only carbon only. Now in this representation, With respect to nucleus, this is the first shell is the innermost shell, whereas second shell is the outermost shell. Total two shells are there in the carbon atomic model. First shell I can call it as innermost shell, that is most nearer to the nucleus, atomic nucleus, and the second shell I can consider as outermost shell. Now in the second shell, what are the orbitals are present? One is s orbital is there, another one p orbital is there. Now in these two orbitals, how many number of electrons are there? I can figure out, that is equal to 4, and that 4 I can consider as a valency electrons. Now let me see here, I represented in the methane molecule the carbon valency, these 4 electrons, as a red dot. Now coming to the hydrogen, if you see that hydrogen, with respect to hydrogen, if you talk about that, the atomic number is 1. Atomic number 1 means 1 electron only there. Now I can write the electronic configuration for this as like this, 1s1. Shall I represent hydrogen electrons as like this? This is 1, this is an electron of the hydrogen, this is 1 electron of hydrogen, this is 1 electron of hydrogen. Now in this structure of methane molecule, if you observe that carbon, by using its valency electrons, form a covalent bonding with the hydrogen atoms, 4 hydrogen atoms. This is C, carbon sharing, just wait, sorry, if you observe here, carbon by using its 4 valency electrons form a covalent bonding with the 4 hydrogen atoms. If you observe here, carbon 1 electron, hydrogen 1 electron, mutually sharing to each other and form the chemical bond. I can call it as this is a covalent bonding. Now right. Now coming to our point, organic compounds which contain carbon in a covalent bonding. Yes, this methane molecule, if you observe that, this methane molecule I can consider as a organic compound. Because why I am considering this methane molecule as an organic compound? It contains carbon. Yes, earlier I explained 2 phenomena. One is carbon containing compounds are the organic compounds. What is the second thing? The second option is carbon at least have 1 carbon hydrogen single bonded system or covalent bonding system. If you observe this methane molecule, I can consider this is a covalent bonded system. Yes, there are a total 4 covalent bonds are there. I can consider this is an organic compound. In these molecules, regarding these type of compounds, we are going to study about, one is the structure, properties and chemical reactions. Let me see in detail what is the structure in this. Structure, what it explains? Structure explains about structural formula. Structural formula of organic compound. For example, if you see here, this is a one molecule, one organic compound, I can say that. Now, by using this formula, let me know about the structure also. How can I write? Let me see. By using the basic concepts, what is the carbon valency, hydrogen valency, based on these concepts, I can write a structure for this chemical compound, this organic compound specifically. I can write like this. Already you know that this is one. This is another carbon hydrogen covalent bond. This is another carbon hydrogen covalent bond, and this is also another carbon hydrogen covalent bond. If suppose I had taken chloroform CHCl3. CHCl3 is the molecular formula of chloroform. I want to write the structure for this, how can I write? Yes. This is also I can consider as a organic compound itself. Why? Because see here, if you observe the things, chlorine and carbon is a covalent bond example only. Here chlorine and carbon also covalent bonding example. Here also same. But if you observe here, there is another one, carbon hydrogen covalent bond also there. Due to this reason only, I can consider this is an organic compound itself. For example, if I take CCl4, shall I call this is an organic compound? Carbon is there, no? Carbon is there. Shall I consider this this compound is an organic compound? No, because the second phenomena what we had learned, that is at least one carbon hydrogen covalent bond should be there in an organic compound, but it is not existing in this structure. Simply by replacing, see here, one carbon, chlorine, second chlorine, third chlorine, fourth chlorine. CCl4 structure, there is no at least carbon hydrogen single bond or carbon hydrogen covalent bonded system, so that I can consider that carbon tetrachloride as a not an organic compound. Then what it is? I can call it as the CCl4 as inorganic compound. Due to the exception of this phenomena, I can categorize entire this carbon tetrachloride as an inorganic compound, even though carbon is there. It satisfies the first phenomenon, it does not satisfy the second phenomena. That is, at least a carbon hydrogen single bonded system is not there. That is regarding structure. I am going to figure out the structure based on the chemical formula. This is a structural formula I can consider as this is a structure. Right. Structure of the methane, molecule name is methane. I had taken methane as an organic compound. It is a structure and it is a structural formula. I can call it as a molecular formula also. That is also correct. Right. Next, coming to the properties. We had completed discussion about the structure. What is the properties? What type of properties we are going to learn? Let me see. With respect to properties, there are two types of properties are there. One is physical and another one is the chemical properties. This is a physical properties and here it is a chemical properties. What we can learn from the physical properties? What is its state, physical state? How many physical states of matter are there? Here, regarding physical state means whether it is a solid or liquid, whether it is a gas, we are going to, or whether it is a semi-solid, we are going to know about under the heading of physical state. To know about the physical state also, one of the physical property. This is one of the physical property and its solubility. Its solubility also, whether it is a aqueous soluble or whether it is a non-aqueous soluble, how it should be there, whether it is a freely soluble, partially soluble. These type of characteristics we are going to learn under the solubility physical property. And the next category, if you observe that under the physical property itself, we are going to learn about texture. What we can learn in the texture point of view? Texture indicates whether it is a amorphous powder or else crystalline powder. Those things we are going to identify under the texture heading, and that is also coming under one of the physical property. These type of characteristics, color, by physical appearance, what we can identify easily, those things coming under the physical property itself. What is the color itself? Texture also, by observing physical representation of the sample, I can identify that whether it is amorphous or crystalline nature. Best example I can say that, take the sodium chloride. Sodium chloride. One example we are going to use in our food preparations. Sodium chloride itself, how it is going to be existing? By physical appearance we can say that is nothing but it is existing in the amorphous nature. This is one of the physical property. How can I categorize? Okay, this is a amorphous nature. Nature I am talking here. By physical appearance. So I can consider it is a physical property. These are the things coming under the physical properties. And coming to the chemical properties. What are the chemical properties itself? Chemical properties itself. Chemical properties itself means that organic compound behavior with, under the chemical properties heading, we can understand, we are going to learn about the particular organic compound behavior with another organic compounds or another compounds. See here, why I am specifying the organic compound only, we are talking about the organic compounds only. Our main topic is organic chemistry. So that's why I am going to learn about the chemistry of particularly organic compounds only. So I can mention as a organic compounds behavior with another compounds. Whatever the type of compound it is, whether it is organic or inorganic, I don't care about that. But in that particular chemical reaction, one must and should be, suppose I am going to take a chemical reaction itself. It can form a C. In this chemical reaction, one must and should be organic compound itself. And the second one must and should be, maybe it is an organic compound, no matter it is, if it is an organic compound, we are considered as entire chemical reaction we are observing between two organic compounds, or else it can chance to expecting that it is an inorganic compound also. There is two options are there, but must and should be one organic compound is must and should. Because we are studying about the organic compounds, we need to know about the chemistry of chemical properties and chemical reactions of organic compounds. So I want to know about, so in this way, the chemical behavior, I want to know the chemical behavior of organic compound under these chemical reactions. That is the thing we have in this first sentence. In this sentence we are going to learn these type of characteristics of the organic compounds. Coming to the next one, see all these things. Study of structure determines the structural formula. Completed. Right, next one, if you see already what I explained here itself, each and everything I mentioned in the point wise. Study of structure determines their structural formula. For example, I have taken a methane formula. What is a methane structure? This is a methane structure. From the structure of the organic compound, what can I figure out? That is molecular formula or structural formula. What is the composition of the respective structure? We can mention as a formula. In this formula, carbon is 1 is there and hydrogens are 4 is there. So this is the composition of this particular structure, this particular chemical compound. So this is I can consider as a structural formula. Based on the structure, I can figure out the structural formula itself. What is the composition here? Next one. Study of properties includes physical and chemical properties and evaluation of chemical reactivity to understand the behavior. The simply chemical reactions here. How one compound going to be react with another compound to form a new product. This is the things we are going to learn under the organic chemistry heading.